and welcome to the Tech Talk. My name is Miriam, and today we're talking about best machining solution for Blisk. And that's why we have Richard here. He's an absolute expert in this case. Richard, it's nice to have you here.
Yeah, it's great to be here, and I'm looking forward to this discussion today.
First of all, to those who are not familiar with that kind of section, what is a Blisk?
So a Blisk is a bladed disc, also known as an IBR, an integral bladed rotor, and these are found in aircraft engines. It means that instead of having a disc where you put the single blades in, you have one piece of material. And the main advantage of Blisks is reduced weight, a more efficient engine, which leads to reduced fuel costs.
Lower costs, this is always an interesting topic to talk about, for sure. Is there a standard way to make a Blisk?
So not really. There is a lot of know-how involved, and you use different techniques depending on the characteristics of the Blisk. But Blisks are high-value and complex components made from these hard-to-mill materials like titanium and these superalloy materials. I think that many companies are worried about the risks associated with producing such high-value components. But if they manufacture the parts on the correct machine tool and with the correct technology, they can be made efficiently, safely, accurately and profitably. So this is a growing market globally, so obviously very interesting for Starrag, and that's the reason we've launched some optimised machine tools for Blisks for big and small bladed variants.
Richard, that sounds very interesting. Can you explain to me and the audience the different strategies?
Yeah, so generally we have two different strategies. So for the smaller bladed Blisks, we use a technique called tip entry, and that's where we drive the tool around the blade, starting at the tip until we reach the root. For the roughing of the blades, this can be done with, say, trochoidal, plunging, or slot milling techniques. It depends on the characteristics of the parts. For the large bladed Blisks, we use a technique called side entry, and the advantage of this is that you can use shorter and more stable tools, which is very important when you're cutting these hard materials. So the large bladed Blisks can be either made from solid, or often the blades are linear friction welded to the hub, and then our challenge is to measure an adaptive mill to achieve a perfect blend in the intersection area.
That makes sense. But tell us, what makes this machine better than other ones?
Well, this is one of the challenges and why you can't really achieve the perfect blend on a standard 5-axis machine. So when you mill from both sides, you have to ensure that the tool paths blend perfectly. Mismatches are not allowed.
Right.
So to avoid that, on our machines, we have displacement, temperature and vibration sensors, and these are operating live during the whole cutting process. Furthermore, we have axis compensation devices, and with all this data, we know where the machine is positioned to within microns. And then we're able to place the tool in exactly the right position, for example, after a tool change or when you're doing side entry. And then that's how we achieve these perfect blends. So this makes Starrag different to the others.
Richard, is there any turning required on these components?
So normally the parts are turned or pre-turned before they come to our machines, but all our machines do have turning functionality. So for example, you may have a part where there's a turn feature with a close tolerance relative to the blades. So with our machines, you would be able to process both features in the same setup and on the same machine to achieve that quality.
Richard, I assume blade quality must be very important, right?
Absolutely, yes. So it's critical on a Blisk that every blade has the highest quality. So cutting blades on Blisks poses challenges for any 5-axis machine. So you have 5-axis simultaneous motions, you have these tough materials, and then you have to achieve tight tolerances. Furthermore, the aero engine designers are now utilising more twisted and complex aerofoil shapes to make the engine more efficient and give more performance. And furthermore, these blades are getting thinner, which makes them prone to chatter and vibration. So this is why most of our customers work very closely with us together, and we develop the optimum technology for their application.
It sounds like these parts are running on the machine for a very long time. Is there any need for automation?
Well, it's a good question. You're right to ask this. So a typical Blisk is running on the machine for many hours. We do have pallet workpiece changers that can change the parts automatically on an unmanned basis. Plus, some customers are now asking for complete automated solutions themselves, including the additional operations like turning, washing and measuring.
Yeah.
So with our existing know-how and our automation experience, our customers can benefit from a multi-machine, lights-out process for Blisk manufacturing, and we think this is the future.
This is the future, I definitely agree. So let's talk about the 5-axis machining of Blisk. This is actually a very important topic, right?
Yeah, so we have different products depending on the size of the Blisk. For the large Blisk, we have the NB351 that can make parts up to 1,100 millimetre in diameter.
Wow.
And then we have the smaller NB251 for Blisks up to 750 millimetre in diameter.
Very good, wow. And there is actually a new one, the NB151. What makes this machine so special?
Exactly. So this machine is focused on a single application, the milling of Blisks. So the NB151 is a very dynamic, a very powerful, and obviously a very precise machine tool. So this machine has been uncompromisingly designed to machine Blisks in the most productive way possible, so that our customers are able to produce these parts at the world's lowest unit cost, which gives them a crucial advantage over the competition. So besides the machining of Blisks, the NB151 is also ideal for milling impellers, which poses similar demands on the machine tool.
So Richard, tell me, if I would buy an NB151, could I produce Blisk at unrivaled unit costs? Is that true?
Yes, absolutely. So we are convinced that we can offer our customers the best solution for processing multi-blade parts through the interaction of our programming software, our technology know-how, and our special cutting tools. This guarantees our customers the decisive competitive advantage: shortest cycle times and zero scrap rate. That's what the NB series stands for.
So this is interesting. Starrag not only builds the machine, they supply the perfect tools for the machines as well.
Yes, Miriam, that's correct. So for the best performance of the machine tool, you need the best cutting tools. So what would be more obvious than Starrag making our own cutting tools? For stable machining of unstable workpieces, Starrag designs and manufactures part-specific tools. And this gives our customers increased productivity, which helps them reduce their part costs. This is another important factor to be able to offer our customers the best solution.
Sounds excellent. Richard, Starrag makes a promise to the customer, engineering precisely what you value. What does this mean for Blisk production?
So Miriam, we don't want to just offer the customer a machine tool. At Starrag, we want to work closely with them together to find the best solution for their machining tasks. So this technology partnership, it could be a customer-specific engineering or application development, like CAM programming, fixture tooling design, or automation. To have the overall most efficient process, every factor has to be taken into account. Starrag strives to be a technical partner to all the Blisk manufacturers out there. So only in a close collaboration can a continuous improvement in productivity be achieved.
I strongly believe you presented us something really interesting. I think it's time to summarize. Can you do that for us?
Yes. So our customers will have the lowest cost per part due to the very fast milling time and the tune process. They will have an optimized machine design specifically for Blisk manufacturing. With the self-calibration, measuring and correction cycles, this will ensure that the machines are geometrically correct to reduce the maintenance requirements and costs. We have intelligent and flexible automation systems to enable lights out, unmanned operation. And finally, energy efficiency systems that can save many thousands of dollars in running costs per year.
So you could say Starrag is pushing the limit with quality and innovation, right?
Yes, absolutely, yes.
It was a pleasure to talk with you, Richard.
Pleasure for me as well, thank you.
And I hope so. You liked it as well. It was for sure not the last tech talk, so make sure you tune in next time as well. See you next time. Thanks for watching.